Thanks for coming. My name is Yalong Yang from Harvard University. Today we are going to look at how to navigate in an immersive visualization. This work is collaborated with Maxime Cordel, Johanna Bayer, Tim Dwyer, Kim Marriott, Hans-Peter Pfister. The display space is always limited and can only show part of the information. What if you want to go to a specific location outside of the current screen, like the marked one? Panning is a basic navigation method which allows you to go to different places. However, without knowing where to go, panning alone is not effective. Additional interactive support is essential. Zooming scales the view up and down. The user can first zoom out to an overview to identify the location of the target, and then zoom in to check the details. Another option is using Overview plus Detail technique. In an Overview plus Detail interface, we use a small window to show the full information space, and the rest of the display is used to show the detail view. As we can access the full information in the overview, we can easily figure out which direction we should move or pan. These navigation techniques has been extensively explored on 2D screens. Cockburn and his co-authors published a survey reviewing 2D navigation methods and user studies in 2008. There are also many papers after that. However, this research only studied navigation techniques on traditional 2D screens. But how about we enlarge the display space like a dozen times, and even with one more dimension? What interactive support should we provide for navigation? This is the problem we explored in this project. One obvious direction is looking at these two well-established navigation methods and figure out how to adapt them into 3D immersive environment. Let us look at zoom first. There are two widely used zoom mechanisms, mouse scroll and pinch to zoom. Mouse scroll are commonly used on desktop, for example, Google Maps in the browser. Pinch to zoom uses the distance between 2 points to decide the scale. It is more common on touch screens. Both mechanisms are familiar to people. However, when using mouse scroll to control the scale, the motion is abstracted to a unit scale, while in pinch to zoom, the motion is directly mapped to a continuous scale. Meanwhile, pinch to zoom requires a multi-touch input system to work. Considering the embodied nature of an immersive environment, we choose to adapt the pinch to zoom method. We use two controllers as the multi-touch inputs. However, we found a new challenge. The knife pinch to zoom method only considered the scale of the object, but during the zoom, the user may also move and rotate the object. Only changing the scale may make the object away from the controllers, which obviously affect the user experience. To tackle this issue, we implemented a latched pinch to zoom mechanism, which allows the controllers to stay at the same relative positions to the object. Here, we demonstrate how we can zoom, rotate, and move a visualization at the same time in the immersive environment. Next, let's look at the Overview plus Detail. Following the basic idea of overview, we duplicate the full 3D immersive environment to a minimap. Although this basic concept is simple, there are many other design decisions for an immersive overview. For example, where we should place the overview. On a 2D screen, the overview is usually placed at a fixed location, for example, the bottom right corner. Following this idea, we attach the overview to the bottom right corner of the field of view and allow the user to pick it up. We piloted this idea with two participants. Both participants found the overview distracting and cluttered. We came up with another idea. We attach the overview to a controller, so the user can easily hide and access it with simple arm movements. We also shrink the size of the overview by default and allow the user to enlarge it by simply put another controller inside. The user can also grab the overview, move or rotate it, and see it from different angles. When creating an overview for a 2D visualization, it is important to indicate the region of the detailed view in the overview. Following the same idea, we created an object showing the real-time position and orientation of the user. This is useful for many scenarios. For example, here, the user noticed that the yellow target is on the left to the indicator in the overview. then she can simply turn left to find the target in the detail view. We also allow the user to use the overview to teleport. Let us first introduce a drag and drop teleportation. The user can pick up the point of view indicator and move it to a new position, and then release it to teleport. We also provide another way to teleport, point and click teleportation. The user only needs to move the controller to the target he wants to see, and then click to teleport. We designed and conducted a control user study to understand the effectiveness of these different navigation methods. The baseline condition is the one without any support. We also have the zooming condition and the overview plus detail condition. We can certainly have a condition with both the zooming and the overview plus detail. In this condition, the user can rescale the view, move in space, and also take advantage of the overview to teleport. We also allow the participant to use the pointer teleportation in all conditions. We use the scatter plot as a testing visualization. We randomly sampled points from MNIST and used Disney to create the scatter plots. We identified two most fundamental tasks for scatter plot visualization that require the participants to navigate to the fine detailed information. The first task is to compare two distances. We also found that whether the user can see 2 points in a pair together may affect the results. So we have the close condition that the 2 points in a pair are close. We also have a condition that the 2 points are far away. The other task is counting the points. The participants were asked to count 3 groups of colored points and reported back the group with the largest number of points. We recruited 20 participants for our user study. We collected time accuracy for each trial. We also recorded the moving distance and the number of interactions performed by the participants. Participants also reported their subjective ratings and rankings. Next, we are going to answer a series of questions with our collected data. The first question we would like to answer is having an overview beneficial? With the testing conditions we have, we can look at the 2 comparisons. We can compare these top 2. We can also compare the bottom 2. Let us first look at the top 2. The arrow bars are showing 95% confidence intervals. The dashed lines connecting bars are representing comparisons with significant difference. We can see that adding an overview can increase task accuracy in distance closed tasks. However, it also introduced extra time cost. We also look at the number of teleportation performed by the participants. We found having an overview reduced the number of teleportation in some tasks. We also asked participants to rate their confidence from low to high. We found participants felt more confident with an overview. Let us look at the other pair, zooming interface and zooming interface with an overview. We found having an overview for a zooming interface may not be necessary, as the performance was similar. Sometimes having an overview may even be disturbing for some tasks. Previous research found similar results on 2D screens for comparing zooming interfaces with and without an overview. Since having both zooming and overview was not effective, we will not include it in the following discussion. Please see our paper for details. The next question we want to answer is which interactive support is better, zooming or overview plus detail. We can see zooming was faster in the distance far tasks, while overview plus detail were more accurate in the distance close tasks. Looking at the participants' feedback, we found participants liked to have 2 scales of views and thought overview to be convenient for finding targets and moving around. However, some participants also commented that teleportation using the overview breaks spatial continuity as you suddenly jumped to a new place. On the contrary, in zooming, people liked the way it provides continuous navigation. The pinch to zoom gesture is embodied and continuous. However, people also complain that they need to zoom in and out many times. We then look at whether participants perform better with moving the object or move themselves in the immersive environment. We found participants were faster when moving themselves than moving the object. This partially aligned with the previous study, which found participants without much gaming experience preferred to move themselves in VR. Most of our participants classified themselves as not playing games regularly. In summary, we found adding an overview to the baseline condition can increase accuracy for some tasks, Adding an overview to a zooming interface seems unnecessary. Overview plus detail was more accurate than zooming interfaces in some tasks. Zooming was faster than overview plus detail in some tasks. Physical movement was faster than object manipulation in some tasks. We can see there is no clear winner for all conditions. From the results, we found the baseline condition performed generally well, especially in terms of time. However, when looking at the camera moving distance, we can see the baseline condition required significant more physical movement than other conditions. When looking at the number of teleportation, we again found that the baseline condition required more teleportation. We also noticed that baseline condition was ranked as the worst by our participants. Our participants complained it to be difficult for finding the targets. So all this should lead to extra time cost. However, the baseline condition performed generally well. We want to figure out what happened. We found that navigation is a complicated process with multiple components. We identified 4 components from the literature. Wayfinding is the process of finding the destination. Travel is the modal part of getting to the destination. Number of travel can be different in different conditions. Context switching is when the user gets into a new location. She needs to reinterpret the new environment based on expectation. We then analyze the performance of our tested conditions in each component. For wayfinding, we believe overview plus detail has the best performance, as the user can use the overview to find the targets at all times. Zooming with an overview also provides a minimap, but participants found it disturbing. In the zooming interface, the user can only zoom out to have an overview, so she cannot access the overview when looking at the details. In the baseline condition, the user does not have any support for wayfinding. We used our collected interaction data and the user's comment to analyze the travel and number of travels components. Due to time constraint here, we only present the results. Please see our paper for details. For the context switching performance, we believe the zooming interface has the best performance as it provides a spatial continuous experience. In the baseline condition, the physical movement also has a spatial continuous experience. However, participants also performed a significant number of teleportation, which introduces context switching cost. When teleporting with an overview, the user can hardly estimate the destination, which we believe has the highest context switching cost. Based on our analysis, we believe the overview plus detail interface has a great potential, as long as we can improve the performance in the number of travel and context switching. We proposed a few directions in our paper. Our navigation time cost model can also be used for task analysis. This is to understand which component is more important for a specific task. Please see our paper for details. In summary, we are the first to systematically explore overview plus detail and zooming interfaces for immersive visualizations. We conducted a user study comparing 4 navigation methods. We also proposed a navigation time cost model, which can be used to analyze navigation methods and tasks. Thank you very much for your attention.